Okay, this is Mr. Boyette, and today we're going to be talking about the steps of the scientific method. Now, science is really just a process. It's a process that goes from point A to point B with many steps in between, and that process is what's led to all the discoveries that fill your textbooks and all the videos and TV shows you ever watched and how all the equipment, all the technology you have around you. It's all been it's all brought to you by that process of science, and that's that method, that scientific method we're going to talk about. And so, like it says right here, that it has many steps. And the thing is it's simply something that we automatically do whenever we get a problem. We automatically go through these steps. And so really, I'm going to put some words to it. But if you Googled it, if you got on the internet and you Googled scientific method, you'd come up with so many different terminology, different words that people use to organize those the process that we naturally go through as scientists and organize it into a stepwise manner. And so let's look at them. First of all, we use the scientific method to either answer a question or solve a problem. I mean, it could be something as simple as needing to change the light bulb in your room. When you walk in, you have a problem and you got to figure it out. And it could be something as easy as that, or it could be trying to cure cancer. And so in order to do that, obviously if we're trying to cure cancer, it's going to take many more steps, and we're going to be asking a lot of questions that nobody has answers to. And that's when we really need to organize our thoughts and our steps, and that's why we have the scientific method. So the first one, being able to solve that problem or ask that question. And in order to do that, you have to have a certain level of knowledge, and that knowledge comes through either through observation or research. And so, I mean, a lot of times when you're trying to solve a problem in scientific method, or in science or any kind of problem in your life, you don't really have all the answers. You don't really know enough about the problem. So you have to either, we run into this all the time. You get on the internet and you Google it, you do some kind of research, figure out a little bit about the problem as much as you can so that you can ask bigger and better questions. And so the next part is actually asking the question. And we call that the hypothesis. And I'm sure you've all heard of that before. And if I ask you what a definition of a hypothesis is, most of you would say an educated guess, which is true. But it also has to be testable. I mean, because that's the whole point of the scientific method, is to be able to test the question that you're asking, be able to test whether or not you can solve it. And most of them look like this example right here. It says, if soil temperatures rise, then plant growth will increase. And if you notice the two words there, if and then. And so most statements in hypotheses are if-then statements. If I do this, then this is going to happen. The next one, based off of that question, we have to develop an experiment. And now experiment, it's a process where we can't really go into it right now. That's a later class, but it's a process with many procedures and detailed materials lists and stuff like that. Now, after you go through your experiment, then you obviously have to collect and analyze your data that you get out of that, and that's the next step. And so, like, if I was going into my room and I'm trying to figure out, why is my light bulb not coming on, or why is my light not coming on in my room, I'd have to first come up with an idea of what it is. Say the light bulb is burned out. Then I have to go through and do the experiment, change out the light bulb. And so if I change out that light bulb, and the light comes on, then I know that's what it is. If I change out that light bulb and the light doesn't come on, then I know that might be something else. And so that's going to be collecting the data. Did the light bulb come on or did it stay off? And so the next one is the conclusion. So you can conclude if the light bulb stayed off that it wasn't the light bulb, there was some other problem. Or you can conclude if the light bulb came on that that was the problem and we solved it. Now, if it didn't solve the problem, then we have to actually go all the way back up and we have to look at, back at the very top, our observation, our research. We have to realize that we have to have some kind of knowledge about electricity to ask even bigger and better questions. And this is where science really comes in, the research. And so a lot of scientists just do pure research where they're trying to answer questions that have never been asked before. And if we're trying to do that and we're gaining knowledge stepwise in this scientific method, this manner, then what happens is over the years, over the centuries, we gain knowledge, and that's how you get all this information that fills our textbooks. And that is the scientific method.